Lepak from the University of Wisconsin, and I am here to present my poster on the pharmacokinetics and pharmacodynamics of a novel nystatin-like drug, ESCMID, in invasive pulmonary aspergillosis and invasive candidiasis. So nystatin is in the polyene class, and so it has very wide efficacy. And we chose to study this nystatin-like drug, ESCMID, using two models, an invasive pulmonary aspergillosis model in mice and an invasive candidiasis model in mice. The methods are shown here, and I'm not going to go through all of them for the sake of time, but this was a standard invasive pulmonary aspergillosis murine model, so they were immune compromised with cyclophosphamide and steroids, and a standard invasive candidiasis mouse model where, again, they were immune compromised with cyclophosphamide. We'll jump right ahead to results here, and we have a very large table showing the in vitro activity of ESCMID against the various strains that we used for Aspergillus in Candida. We had 3 Aspergillus fumigatus strains, 4 Candida albicans, 3 Candida glabrata, and 4 Candida auris. And you will note, I'm sure, right away that the MIC variation was extremely small. In fact, there was no variation. They were all an MIC of 1. And this is common with the polyene class. The same thing is noted for things like amphotericin B. The growth in controls is also shown here, which I want to direct you to show that these were very fit organisms. They grew extremely well in the animals. Almost all of them between 2 and 3 logs. To the right of the table, we have the pharmacokinetics in mice, and I'm not going to go into too much detail on the PK study per se, other than to bring attention to the fact that it was extremely linear, and the half-life was quite prolonged in mice, which is a little bit unusual for many molecules. Underneath the table, we have the dose-response curves. These are standard dose-response curves that you're pretty used to seeing, I'm sure, where the dose is along the x-axis and the change from the start of therapy is on the y-axis. So points above the dashed lines are net growth, and points below the dashed line is net cytal activity. And you will note for each of the 4 organism groups, we had quite a bit of activity as concentration increased along the x-axis. To the right of these dose-response curves, we then have the regression analysis for Cmax to MIC. We chose Cmax to MIC because that is often the best PK/PD predictor of efficacy for the polyene class. And so the different regression analysis are shown along the far right, and you will note quite good fits for each of the 4 organism groups in terms of Cmax to MIC and therapeutic effect. And then in the second table on the poster, we have simply the PK/PD estimates for net stasis. And so we have the 24-hour AUC to MIC and the Cmax to MIC shown as both can be good predictors of effect. And so with that, I will end with some conclusions, and that's that this molecule demonstrated potent effect against 4 different groups in Aspergillus and 3 different Candida species. The PK was very linear, and the half-life was quite prolonged. Similar to other polyenes, we saw a nice concentration-dependent effect with Cmax to MIC predicting effect quite well. And the PK/PD targets were somewhat lower than what we've seen with other polyenes. So Cmax to MIC, the median value for Aspergillus was only 1.4, and for Candida albicans, the Cmax to MIC for net stasis was 0.6, for glabrata 0.22, and finally for auris 0.48. And again, those are numerically lower. For many Candida, the Cmax to MIC is usually around 2, and for Aspergillus, it's usually around 2 to 4. So that was a quite interesting result. You're always welcome to contact me anytime, and thank you for listening.